Hello everyone! Today we're doing LeetCode 3556 sum of largest prime substrings. At first I actually misunderstood the question, so I had to start over it 2 times. But basically you have to find every substring of the given string you have and then convert them into numbers. And then you have to find 3 of the largest prime numbers. And that's basically it. So I'm just creating a helper function called getSubstrings, which will get every single substring of the given string. And this is pretty straightforward. It's basically just brute forcing everything. So I have one for loop for the iteration of the beginning letter, and the second for loop is to iterate every possible ending letter. And then I just have to add every single substring from beginning to end for every beginning to end character, if that makes sense. And then I also thought that I should probably return it as a set instead of like a list, because we only want unique numbers and not like in a particular order, which makes sense for this problem because we don't really care about the order, right? And also I had to change the return type to be integer because we actually want integers and not strings. And I'm just changing everything so they can be converted to integers. This is actually a bug here which I had to fix later because we actually need long, not integers, as integers might have overflow because the numbers can get very big. But I didn't actually notice it at this point of me writing the code. So yeah, instead of using a set, I'm using a tree set, so everything is sorted in order. So I don't have to go out of my way to sort them later. By the way, I'm actually recording this live during a LeetCode competition, and it's been quite some time since the last time I did the LeetCode competition. I will try to record more if I do competitions in the future. Okay, so now I have another function, a helper function called isPrime, which will check if a number is a prime number. To do this, you simply have to loop through the numbers from 2 to the square root of the given number, and then just check if each of these numbers are a factor of the given number. If so, then it must not be a prime number. If not, then it has to be a prime number. We don't have to check any numbers from the square root of the number onwards. Think about it. If n equals to a times b, then only checking the smaller number of a and b is sufficient. But if a equals to b, then a must equal to square root of n, and so does b. And as long as we got these 2 helper functions, then we simply just call them in our main function. And all we have to do is to take the last 3 entries of the tree set, because the tree set automatically sorts everything. So we no longer have to call another sort function to do that. By the way, I actually got here confused with Python because a lot of my assignments in the current courses I'm taking are in Python. And in Python, you can just call the index using negative numbers to indicate the last numbers. But in Java, that does not work. You have to do len -1 instead of -1, so on and so forth. And another thing I was missing here is that I just assumed that there is going to be at least 3 prime numbers, which they made it sound like we could just assume that because they said to return the 3 most frequent prime numbers. So it seems like you have to have at least 3, right? But that's not the case. So if you have only 1 prime number or only 2 prime numbers, you have to specifically check for that and make sure you only return 1 or just 2 numbers if that is the case. And then after fixing everything, after changing my integers to longs, that fixed all of my problems and I was able to pass this question. If you enjoyed this video, please kindly like and subscribe. It really means a lot to me. Thank you so much for watching, and peace!